Hello friends, welcome back to our channel. So today we'll see one more concept in design and analysis of algorithm, that is how to calculate the time complexity of any algorithm or any pseudocode. So before going to calculate the time complexity, we'll see what are the steps we need to remember before calculating the time complexity. So the first step, we need to identify the number of blocks in algorithm or a pseudocode. So identify number of blocks in algorithm or pseudocode, right? Or in a program also. So here the number of blocks means declaration can be considered as a one block, initialization statements may also be considered as one block. Similarly, iterations, the complete iterations, if it is a nested loops, then the complete nested loop should be considered as a one block. And similarly, conditional statements. So if the conditional statements used in the algorithm is if else, so both we have to consider as a single block. Okay, so first we have to identify the number of blocks, and for these two always the time complexity will be the constant. Okay, so time complexity will be constant. So constant means big O of 1. We can say constant as big O of 1. And for iterations and conditions, so here if it is a nested iterations, we have to use a multiplication for nested loops. Either it may be a for loop or a while loop. So if it is nested, then we have to use a multiplication. So we have to find out the time complexity for each and every loop and we have to multiply. Okay, so first we have to calculate the time complexity of the inner loop and the time complexity of the outer loop, and both we have to get multiplied. And if it is a conditional, then we have to choose either, because the conditional means only one block will be get executed, either if block or else block. So we have to consider only one case, either if case or else case. So we can write here, so maximum of if or else. So this is the time complexity of if block and time complexity of else block. So we have to consider only one thing. And if it is a nested if else, so calculate the time complexity of each and every block and find out the maximum among all those conditions, right? So if our code is having some 2 conditions or 3 conditions, we have to calculate the time complexity of the 3 conditions and find out the maximum. So we have seen the growth rates from smallest to largest in our previous session. So select the maximum time complexity among this one if it is a conditional. So then what we have to do, avoid the constants. So you can avoid all the constants. For example, if time complexity is 2n, you can avoid 2. If the time complexity is n by 2, avoid 2. Okay, if the time complexity is n plus 1, avoid 1. So like this you can avoid all the constants in our time complexities. Okay, and simply add time complexity of all blocks. Time complexity of all the blocks we have to add. For example, so add the time complexity of declaration, add the time complexity of initialization, add the time complexity of iterations if it is having, and add the time complexity of conditional statement if it is having, right? So add each and every block, the time complexity of all the blocks. And finally, the time complexity will be the highest order in equation. So if we apply all the addition of all the time complexity of all the blocks, the highest order will be the time complexity, final time complexity. Okay, so these are the points we have to remember before calculating the time complexity. So if you understand this one, and it will be very easy to calculate the time complexity for any type of algorithm and any type of code. And here one thing is we have to remember, so coming to the iterations, there might be a dependency or there might be an independent. So there you have to carefully find out the time complexities, right? So in the iterations we will be having the two categories, dependent, independent, right? So if they are independent, this process is final, right? So multiplication of nested loops. And if it is dependent, we have to trace out and we have to calculate the time complexity, right? So whatever the process we have we have explained here, the multiplication will be suitable if the iterations are independent, right? So hope you understood the rules or the points we have to remember, so before calculating the time complexity. Now we'll see small examples, so how we can calculate the time complexity, right? So simple codes, I'll write the simple codes and I'll tell you the time complexity in this video. In our further video, we'll go with the small complex, right? So example 1, let us take for I is equal to 0, I less than or equal to n, and I plus plus. So let it be some any statement is here. Now just check. So this is the block of statements need to be get executed. How many times it is going to be executed? So how many times it will be executed? So until I value starts with 0 and until I becomes less than or equal to n, that means I greater than n. Until I greater than n, this block will be get executed. For example, n plus 1 times. Okay, so n times it will be executed. If it is n plus 1, then it will be false and it will not be get executed. So it will be n plus 1 times, right? N plus 1 times. And what we have seen, so we have to avoid the constants. So avoid these constants. So the time complexity of this particular code will be order of n, big O of n. So always the time complexity will be represented using the worst case scenario, that means order of n, which gives the upper bound. So in the competitive questions, if you get this type of problems, so if you found any other time complexity like n square or order of log n log n, right? Order of n cube, right? So everything will be correct for this particular thing. So because this is the worst case and it gives the upper bound of the time complexity. That means so n and greater than this order of n can be correct for this particular code. Okay, so this is the time complexity of this one, order of n. So let us take one more example. So for I is equal to 0, I less than or equal to n, and I is equal to I into 2. So what happens here? How many times it will be executed? So now we have to trace. So when I is equal to 0, right? 0 less than or equal to n. If it is true, consider if it is true, I value will become, sorry, let us take 1. So I value become 2 less than or equal to n. If still it is true, I is equal to 3 less than or, sorry, I becomes 2 into 2, 4, right? So 4 less than or equal to n. Now I becomes 8 less than or equal to n. I becomes 16 less than or equal to n. So like so on. So whenever I becomes k, then k, sorry, you can see that, see 2, this can be written as 2, this can be written as 2 power 2, this can be written as 2 power 3, this can be written as 2 power 4, and so on. So we can get it as, we can write it as 2 power k less than or equal to n. So this many times it will be repeated. This many times it will be repeated. So now what? So avoid this less than. So we can simply write it as 2k is equal to n. Now what is the k value? If you have this one, simply this is a formula logarithmic log n base 2. So the time complexity of this particular code will be log n base 2. So the time complexity is equal to, we can simply write it as order of log n. So always it will be base 2. Okay, you need not worry about that. Always it will be base 2. So log n base 2. So if it is 3, what happens? So I becomes 3 here, and here it becomes 9. Here it will becomes 27, and here it will becomes some 81. So here it will be 3 square, 3 cube, 3 power 4, and it will be 3 power k, and it will be log n base 3, and it will be base 3. Right? So like this we have to trace and we have to calculate the time complexity. So we'll see one more. So this is a order of n which we call it as a linear, and this is a log n which is called as a logarithmic. Now we'll check one more. For I is equal to 0, I less than or equal to n, excuse me. Again, for j is equal to 0, j less than or equal to n, j plus b. And see, this is a code. Let us see. So we know that this is a nested loop. So not only with the for loop, we can also go with the while loop also, the same procedure. So coming with the inner loop. So how many times this inner loop will be get executed? So from 0 to n. So is there any dependency? There is no dependency, because j will iterate from 0 to n, I will iterate from 0 to n. For example, if in between, n is replaced with I, okay, in the place of n if it is I, then it will be the dependency. So j should be depends on I, how much the I value, right? So that we will see in our further sessions. So now we will see only the simple things. So this is a independent, no, there is no dependency. So j will be iterating from 0 to n, and I will be iterating from 0 to n. So there is no dependency. Now, so how many times if this inner loop will be executed? So n times. Then how many times the outer loop will be executed? Obviously n times. So in our first minutes we have discussed that if it is a nested loop and there is no dependency, we have to multiply the time complexity of each and every loop. So here we have to multiply, so time complexity will be order of n into n. We can call it as a n square. That's a quadratic. Such type of complexities, right? So there is no dependency. And see, if the same thing happens with another for loop, for k is equal to 0, some k less than or equal to n, k plus plus, and see, for example, it is like this. The code is like this. Okay. So what happens? There is no dependency. 3 are independent. 3 loops are independent. So again calculate here, which is n times. So obviously the time complexity will be order of n into n into n, which is order of n cube, a cubic complexity, cubic function. Okay, and see, hope you understood this one. So if there is no dependency, simply we can multiply all the time complexity of each and every loop. And now consider this one and consider it is m and it is n. Then we can say the order will be m into n. The time complexity will be order of m into n. So simply we have to multiply the time complexities of each and every loop. Yes. Now, see. So we'll see. Write down some condition. If some I or any condition, write down any condition. No problem with the condition. Any condition. And inside we are writing some loop for I is equal to 0. I less than or equal to n, I plus plus. There is a code, and here again else part. Again here I am writing for j is equal to 0, j less than or equal to n, j is equal to j into 2. Right? So what happened here? So this is a condition. So if it is a conditional statement, what we have done, so we have to find out the time complexity of each and every case. That means if block and else block, and we have to consider the maximum order. So what is the time complexity of this one? So only one loop is there. So this loop will be terminated till n, I value greater than n. That means n steps. So n times. What about the time complexity of this one? J is equal to 0, j less than or equal to n, j is equal to j into 2. So just now we have seen a similar example which gives the logarithmic, right? So that is the log n times. So what we have to consider? So this is not an iterative, so we should not multiply these two things, right? So this is a conditional statements. So we have to consider a maximum order. So among these two, which one is the maximum, n or log n? So obviously we have to refer the growth rate from smallest to largest. So in that growth rate you can see n will be the largest among these two. So we have to consider this one, right? So now the time complexity of this type of problems, so which gives the time complexity order of n. So maximum of n and log n. So which gives this one, order of n, right? So this is an iterative. One more example. We will see one more example. Hope you are understood, right? So I am saying about all the different cases, right? So then you can practice on your own. See, for I is equal to 0, I less than or equal to n, I plus plus, and inside the for loop again I am writing for j is equal to 0, j less than or equal to n, j is equal to j into 2. So this is a code, right? So what happens? So both are independent, no dependency, right? Both are independent. So the time complexity of this loop will be log n. Just now we have seen, right? Log n. and the time complexity of this one will be n times. So here there is no dependency. Here these are not the conditional statements. So what we have to do, we have to multiply the time complexity of each and every loop. So the time complexity of such case, what is the time complexity? We'll get n log n, the order of big O of n log n, big O of n log n. So this will be the time complexity. Okay, see, last example, I'll close. So let us take void main int, let us take some I is equal to 0. For I is equal to 0, I less than or equal to n, I plus plus, and I'll write here printf welcome. Right, close. So this is a code I'm having. Now how to find the time complexity? See, this is the declaration. This will be the one block, and this is another block. So you can consider it as a block 1, block 2, and this completely comes under block 3. Okay, so this will be executed only one time. So one time, and this will be executed only one time, and this one, how many times it will be get executed? N plus 1 times, because if I becomes n plus 1, then only the loop will be terminated. So n plus 1 will also be executed. So it will be n plus 1 times. So what we have to do? So we have to add the time complexities of all the blocks. So we have to add the time complexities of 1 plus 1 plus n plus 1. So how much we get? N plus 3. And then we have to avoid the constants, right? So avoid these constants. So the time complexity will be order of n. So like this, we have to calculate the time complexity, right? So first we have to identify the number of blocks, and then we have to find out the time complexity for each and every block, and next we have to add the time complexities of all the blocks, and we'll get some equation. Avoid the constants in the equation and consider the highest degree among all the terms in the equation, so that will be the worst case time complexity. So usually we represent it as big O of n, right? So hope you understood this one. So in this session I have explained you about the complete basic problems. So in our next session we'll move on with a little bit complexity, right? The code with a little bit complexity. So we'll see some problems, and then you will be getting a complete idea about how to calculate the time complexity, and you have to keep on tracing the problems, and you have to solve the problems. Then you will be strong in finding the time complexity of any kind of algorithm or a problem, right? So hope you understood this one, and if you are having any difficulty in any one of these topics, feel free to post your doubts in the comment section. Definitely I will try to clarify all your doubts. And if you really enjoyed my session, like my session, share my session with your friends, and don't forget to subscribe to our channel. Thanks for watching. Thank you very much.